So what is SolidWorks? Well, this may seem like an obvious question. It's a CAD tool, right? Besides being a very user-friendly CAD tool, I'd like to tell you a little more about how it behaves before jumping right in. SolidWorks is a parametric, feature-based system that allows you to create 3D parts, assemblies, and 2D drawings. A parametric modeler behaves differently than other more primitive CAD tools that are object-driven. What I mean is, in a parametric modeler, everything is controlled by either parameters, dimensions, or relationships. For example, if you want to move the position of a hole that's in a block, in a parametric system, you would change the dimension or relation that controls its position. The parameters and relationships you set up allow you to have control as a designer over something called design intent. The term design intent basically describes the way your design will behave depending on the way you design it. By using parameters and relationships, this gives you ultimate control over the model. Here in this example, I'd like to center this circle within the rectangle. I know the rectangle is 4 inches by 6 inches. One way to center the circle is to dimension it 2 inches from one edge. And 3 inches from the other edge. That centers the circle on this rectangle. But does this capture my design intent? Well, let's see what happens when I change the size of the rectangle to 7 inches by 8 inches. As you can see, the circle is no longer centered, so no, this doesn't capture my design intent. So how can I center this hole so that no matter what size the rectangle is, the circle will always be centered? In a parametric modeler, it's also possible to use relationships. Let's get rid of these dimensions. To create a relationship that centers the circle, I'll sketch a diagonal line using the centerline tool. Next, I'll add a midpoint relation between the diagonal line and the center of the circle. Now, no matter what the size of the rectangle, the circle will always be centered. This is just one example of the countless ways to capture your design intent when modeling in 3D, and we'll talk much more about design intent and these geometric relationships throughout the course. You can see how modeling in a parametric environment can be very powerful. The other huge advantage of this type of system is that you also get associativity between your parts, assemblies, and drawings, meaning if you make a change to the design of a part, the change will take effect in any assemblies that it's a part of, and its 2D drawing will update automatically as well. You can also make the same design change from the 2D drawing, and the part will update, as well as the assembly. This associative behavior saves you lots of time when you make design changes, so that you only have to make the change once, and all associated items will automatically update appropriately.